Hello and welcome. In today's video, we're going to cover chapter 12, IPv6 addresses. So this chapter is part, of course, of the CCNA Introduction to Networks. So things that we're going to learn in this chapter, we're going to actually learn how IPv6 came to overcome the depletion of IPv4. We're going to see the IPv6 structure, how the IPv6 are structured, how many bits in IPv6. We're going to talk also about the representation of IPv6, how we can shorten the IPv6 using two rules. And then we're going to move to IPv6 address types, like global unicast, link local IPv6 addresses. We're going to also see how we can configure dynamic IPv6. We can get an IPv6 dynamically or statically, static configuration. And also we're going to also explain the global unicast addresses, how the host can get them dynamically, or we can configure them statically. And also link local. And we are going to do some packet capturing. I'm going to show you a couple of messages that are actually when a host requests an IPv6 in a router solicitation message, and when the router responds with an RA, router advertisement message. We're going to also see neighbor discovery. And we are also going to end the chapter with how you can subnet an IPv6 addressing. So there is a lot of interesting stuff to learn about IPv6. So let's get started. So IPv6, as you may know, it came to overcome the IPv4 limitations because they are almost exhausted. And the most organization that allocate IPv6 addresses IPv4 addresses, they declare that they are finished since some of them actually since 2012, as you can see here. So for example, the Latin America, so since 2011. In Europe, it's since 2012. And in Asia Pacific, 2014, 2020 in Africa, and 2015 in North America. So that's why we need an not IPv6 that overcome this limitation. And the IPv6 actually is, okay. So the IPv6 is 128 bits, 128 binary bits. Let me turn on my my tablet. So here we go. Yeah, so IPv6 is 128 binary bits. Okay, so yeah, why they choose 128 binary bits? Because the IPv4 is 2 to the power of 32, because the length of IPv4 is 32 binary bits. Approximately, this gives us the 4 billion IPv4 addresses. So it's kind of the IANA, the organization responsible for creating the IPv6, they probably made a huge mistake. That's why, okay, they decide to use 128 bits instead. So 2 to the power of 128 is approximately 3.4 multiplied by 10 to the power of 28, which means 3.4 endecillion IPv6 addresses. Means that each grain of sand on the universe could get an IP, and there is much more. So for the IPv6 and the IPv4, transition is not going overnight. It starts since 2011, but the transition is taking place probably from now to 20 years to come. So the coexistence of the IPv6 and the IPv4, there are networks that run IPv4, there are networks that run IPv6, and so on. So there must be some methods to actually allow the IPv4 networks to communicate with IPv6 networks. And to do this, those methods are 3. So the dual stack method. Dual stack, basically, when a router actually runs both IPv6 and IPv4, that's called dual stack. They maintain separate routing tables for IPv4, another routing table for IPv6. You could run multiple protocols for IPv6 and for IPv4. The second method is the tunneling. So the tunneling method is actually runs, let's say we have an IPv6 enabled network here, and then we have another IPv6 enabled network here, and then right in the middle here we have an IPv4 network. So it's kind of encapsulating the IPv6 inside the IPv4 to allow those network running IPv6 addresses to communicate together, and that's the tunneling, the second method. The third and the last method is the translation. So it's NAT64 that allows the IPv6 enabled devices to communicate with IPv4 enabled devices using NAT translation or network address translation for IPv4. So it's kind of translate IPv6 into IPv4 and vice versa. It's called NAT64. You need to remember those methods for the exam. If you are actually exam candidate for CCNA, you need to remember those methods. So IPv6 representation. So as you can see here on the slide, the IPv6 is 8 hexsets, is 128 bits, and it's 8 hexsets, and it's written in hexadecimal. As you may know, the hexadecimal is 0 from 9 numbers and letters from A to F. A being 10, B being 11, all the way to F, which is the equals 15. Okay, so A, B, C, D, E, F. Okay, so as you can see here, we have 8 hexsets. So 1, 2, 3, 4, 5, 6, 7, 8 hexsets, and each of which have a 16 binary bits. So 16 multiplied by 8 will give us the number of 128 binary bits. As you can see here, the IPv6 are long, but no worries. There are actually 2 rules that you can shorten them. And those rules, rule number 1 says omit the leading zero. So whenever there is a leading zero, you can actually take this leading zero out, taking the 3 leading zeros out, taking the 3 leading zeros here, taking those zeros here, as you can see, and taking the leading zeros here and taking 0 out here. And the shortest version that we are going to get is right here. Okay. And the second rule is actually if you have consecutive hexsets of zeros, like this one, we have 3 consecutive hexsets of zeros. We could represent them with a double column, as you can see right here. So we take those consecutive bits of zeros, okay, and then we can represent them with a double column like this. But we do this only once per IPv6. We cannot do it twice, because imagine if we can do it here and do it also here. Let's say we represent this hexset with a double column here, then we are not going to know how many hexsets are here. So here we have, if we do it here, then we know, okay, right here there are 3 hexsets. Why? Because we have 1, 2, we have 1, we have 2, 3, 4, 5. Since the total hexsets are 8, so 8, okay, it will give us 3 hexsets are remaining here. So 5, okay, subtract 5 from 8, then you will get 3 hexsets right there. If we do it twice here and here, then we don't know how many hexsets are here, how many hexsets are here, so it's caused some confusion. So we only do it once per IPv6. And remember that in the exam, be prepared for questions that are going to give you an IPv6, and probably they're going to ask you what is the correct, okay, IPv6 address. So you need to to know the 2 rules to shorten the IPv6. IPv6 address types. So there are a couple of messages. IPv6 actually have 3 types of messages: unicast, multicast, and instead of broadcast, we use multicast. Okay, so the broadcast is phased away. As you may know, broadcast is a problem. So when a host computer on IPv4 send a broadcast, all hosts, they need to process the broadcast using resources, and that's actually can slow bandwidth, can actually cause a broadcast storm. That's why they phase it way in the IPv6, and instead they use multicast, one to a group instead of one to everybody. And then comes a new type of message. It's called anycast. This is basically one to the nearest. So, for example, when you type, for example, google.com, it will take you to the nearest Google server instead of going to the data center in United States. It could take you to local, probably the data center where the Google servers are located. That's the anycast, one to the nearest. And then, as you can see here, the IPv6 is also two portions like the IPv4. So in the IPv4, we have network portion and the host portion. In IPv6, we have the prefix and the interface ID. And the most of the time, they are 64-bit for the prefix and 64-bit for the interface ID, as you can see here. Regarding the prefix, is the first 64-bit IPv6, okay? Allocated by the router or DHCPv6, and then the ID is actually the host decides how to use the ID. The host append ID to the first 64-bit prefix. There are two ways to append the ID. Either use the extended unique identifier, which is the MAC address, and right in the middle of the MAC address, it inserts like FFFE right in the middle of the MAC address. That's called extended unique identifier or randomly generated, okay, last 64-bit interface ID. So as you can see here, we have the, let's go back. So we have the LLA. LLA is linked local addresses, as you can see here. So the IPv6 address types. We have the global unicast, and then we have the global unicast IPv6 addresses. As you can see here, they start with at least the first 4 bits. First 4 bits. I mean because each hex each digit in hex represent 4 binary bits. So why we get the 2 here? Because the first digits are set to, there is no 8. Let me, there is no 8 here. Let's go back here. So the 2 in binary, let's go back, sorry. So let's write it here. So 2 in hex, so represent 4 binary bits. There is no 8. There is no 4. There is no 1. There is 2, and there is no 0. I need to write this probably here. So it's my point is 0, 0, 1, 0. Those 4 digits for the 4 bits for the first digit are always represented like this. So the IPv6 global unicast, it's called global unicast, GU, global unicast address, or GUA. Okay, so global unicast IPv6 addresses they always start with 2. And we don't care what comes after that. Okay, so let's move on. So as you can see here, we have the another type of IPv6 called linked local address. So linked local addresses basically are not routable. They cannot communicate on the internet. They cannot be used on the internet. And they're like the private IP addresses, the 169.254, the IP addresses .x.x. It's similar to those, and they allow routers to exchange routes between each other. They actually responsible used for sending the ICMPv6 router advertisement, router solicitation, neighbor advertisement, neighbor solicitation, and so on and so forth. And you could even go in here, for example, on this interface right here, and configure the same IP. For example, the linked local addresses, they start with FE80. Remember that. So FE80 : /13. So the first 13 digits are always like this. So FE8, and we don't care what comes after that. And we could even come to this interface here. and give it same IPv6 address. For example, FE80::1, and we give this other interface on the router and same router, different interface, we could give it the same and exact IPv6 address and no problem, because this IPv6 is only means something to the local link. It means something only on this link, and this means only something to the other link. Global unicast addresses and link local static configuration. So for the configuration, we're going to do the configuration. I'm going to actually use EVNG, and we are going to do the configuration. So basically, you go to global config mode, interface type and number, and then IPv6 address instead of IP address. Like in IPv4, we use IPv6 address, and then we assign the address and then the prefix linked. Okay, and then I'll shut down and exit right here. Now let's go to the configuration. So I'm gonna go and let's go to okay, let's actually bring the EVNG. Okay, and here we go. So that's the EVNG, as you can see right there. So yeah, I have a user, a computer or host connected to the switch, and then the switch is connected to the router. So the router will provide default gateway, okay, for us. So the router actually is our gateway. As you can see, the IPv6 that we're going to configure is right here. And then the MAC address of the router of this interface right here. And this is the MAC address of this interface right here. So let's go to the configuration. So what we're going to do here, we're going to configure the router interface gig00 with an IPv6 address, global unicast IPv6 address, and link local IPv6 address. And then we are going to configure even DHCP on this router, so the host could get a automatic IPv6 address from the router. Okay, let's actually do that. So I'm going to open my secure CRT, and yeah, and let's start the configuration. There we go. So yeah, this is my router. So actually, I'm gonna say no, and let's actually okay, wait a couple of seconds. So it's kind of slow. There we go. It started now. Yeah, I'm using I'm running the EVNG on my laptop. I'm looking for a server. Yeah, and it's actually yeah, it's the laptop, as I noticed, is not capable of running the EVNG. That's why I just need to wait for a couple of seconds. So let's open the host as well, the other computers. I'm gonna open the host as well while waiting, and let's go back to our router, and let's see if we okay, so here we go. So enable mode, and then I'm going to go to global config mode. Okay, and then interface, as you can see, it's right here, gig00. So interface G0/0, and then IPv6 address. Okay, IPv6 address. I want to mention one important thing before I go to even to the interface configuration. I'm going to exit. I'm also going to take the volume out from my workstation, because yeah. So one thing that you need to remember in the exam, I think you might forget it. So IPv6 unicast routing. This enable the router to use IPv6. So don't forget this command. If they give you lab on the exam and IPv6 configuration, please don't forget this command. IPv6 unicast routing, it turns on the routing capabilities for IPv6. And then let's go back to the interface gig0/0, then IPv6 address, and then we're going to use 2001. Let me see my IPv6 address, 2001 db8 ACAD, 2001 db8 colon ACAD colon, let's say that, okay, ACAD 10, and then colon, forward slash, colon, 1, and then forward slash 64 for the prefix lint. And then I need to add another IPv6 address, which is link local. So global unicast IPv6 addresses, as you can see, they always start with the 2, okay? And we don't care what comes after that. Those are routable. Those are like the public IPv4 addresses, okay? And then we have the link local IPv6 addresses. They always start with FE80, okay? The first 13 bits, binary bits, actually, they need to match. So FE8 at least. And then we don't care what comes after that. So I'm going to use a 1. And then, as you can see, we need to type the keyword link local. If I don't type it, it will say command incomplete, okay, error. So I'm going to actually no shut the interface, no shutdown. And then I'm going to move to, let me do right mem. I'm going to move to the DHCP configuration. So to configure DHCP on the router, I will need to start with IPv6 DHCP. And then I'm going to specify a pool. And then I'm going to say, let's say branch, okay, 1, and then LAN, okay. Here, let me ask the router. Let me ask the router for the commands that we have here under the, okay. So we don't use default like the IPv4, we use DNS server and the domain name, and then we are exit. So we're gonna configure this too, and then the pool is used under the interface. So I'm gonna show you how you could do that. So DNS server, and then the DNS server is the IP that's reconfigured on the router itself. Let's set it to this IP right here. So let's say the router is the DNS server. You just configure IPv6, and then let's go domain name, and then domain name I'm going to use itgeekshub.com, itgeekshub, itgeekshub.com, itgeeks. There is G there, itgeekshub.com, and then I'm going to exit, and then I'm going to go under the interface. Notice what I'm going to do under interface gig 0/0, and then I'm going to actually use the IPv6 DHCP server, and then I'm going to use the pool name that I used right here. So it's a branch LAN in this case, okay? So I'm going to configure the interface with so basically gigabit 00, it's the interface that will start allocating, okay, IPv6 addresses. That's why we need to configure the pool or the range of IPv6 addresses to be allocated on this interface right here, and then I'm going to hit enter, okay? Then I'm going to add another command, IPv6 ND for neighbor discovery. So neighbor discovery is used actually to translate IPv4 to MAC addresses. It's like the broadcast or the ARP that uses broadcast. So the ND uses multicast. I'm going to show you after a while how we can actually filter some traffic and see some packets regarding the ND traffic. Okay, it uses ICMP to allow the communication between the hosts and the routers as well. And then we're going to use other config flag. So it uses a flag, and then we are going to actually exit and do right mem right here. So in order for that's the DHCP configuration. Okay, so I'm going to go to the host now, and let's actually go to the host, and then I'm going to say no. There we go. Taking a couple of seconds. So yeah, I'm going to say enable, and then config terminal, and then go under the interface as you can see, the interface that I'm connecting facing the router is Ethernet 00. I'm going to go to the interface Ethernet 0/0. Okay, and then I'm going to say IPv6. Okay, IPv6, and then address. Okay, and then auto config, and then I'm going to use the default keyword. Okay, auto config the default keyword. What actually this does, it will use, this host will use a SLAAC or a stateless auto configuration method to get the information, all the information from the router, So it may get the prefix from the router and the other information from the DHCP. That's called SLAAC. And there are actually 3 methods. So SLAAC, stateless auto configuration. So the host gets all the information from the router. I mean the IPv6, the DNS, domain name, and all information, the prefix lint, and so on. Yeah, that's the first method. The second method says could the host actually get the IP or the prefix IPv6 prefix from the router and get the other information from DHCPv6. That's called SLAAC with DHCPv6. And the stateful DHCPv6, it will actually get all the information from DHCP or dedicated DHCP v6 server. Okay, I think we are done. Let me save my configuration, and I should start actually capturing traffic before I run the command. But that's fine. Let's see if we can capture some traffic using Wireshark. I'm sure we can get some messages regarding the RA and RS. And neighbor discovery. So yeah. So let me see if we can get some messages here. Don't get any messages. Let me shut down the interface and do this again. So yeah. So I think it didn't turn the interface on. Yeah, that's great. That's good. That's great. So let's go here. Yeah, it's still open somewhere here. So let me go to the user, and then no shutdown. See what will happen here when I go to my to Wireshark. Yeah, exactly. So that's the messages I'm looking for. So I'm gonna stop right there. So I'm gonna stop now. I think neighbor solicitation. It's emit like that. That's enough. That's enough. So yeah. Let me actually explain what exactly happened here. So I'm gonna I'm gonna actually, let's go to I don't want a multicast listener. I'm looking for neighbor solicitation message. That's the first message. What happened in neighbor solicitation message? Basically, it's the source unknown, as you can see, and the destination is going to FF02::1 FF00. I can see that yeah, this is actually multicast all nodes, multicast IPv6 address FF02::1. Okay, so that's all multicast nodes. So neighbor solicitation. So the user one host is sending neighbor solicitation to the router via ICMP. So neighbor solicitation, it uses, or neighbor discovery, it uses IPv6. Okay, messages, internet control message protocol v6 or version 6. Okay, and then we should get the reply back from the router to the host. It's called neighbor advertisement. So this is neighbor advertisement, and we know from where it's coming. It's coming from let me see here. So it's okay, and it's going to all nodes. The source, I can see that the source address is the IPv6 address, I mean link local address on the host itself. So neighbor advertisement. So it's yeah, I should see neighbor solicitation, neighbor advertisement. So this is basically coming from the user one host and going to all multicast nodes. Okay, it's not destined for the router. And then we have a router solicitation message. So router solicitation message is coming from the user 1, as you can see. That's the IPv6 of user 1. How do I know that? Because we have the MAC address right here, the extended unique identifier, last 64-bit. We have the FFFE inserted right in the middle of the MAC address of the host. Remember, we configured link local with FE80::1 for the router, and then the host get the prefix, get FE80::/64. That's the prefix for link local address, and then it's kind of take the MAC address of the host, as you can see here. So the MAC address, let me show you the MAC address of the host. So it's AABBCC00.6. Yeah, it's actually the same except for the first 2 digits, A8 instead. So it's actually inserting some bits in the, I don't want to dig deeper into this. At least you can see that the it's using extended unique identifier right here. And the message is destined for all routers. So router solicitation from the MAC address, as you can see, it's right there. From the MAC address, that's the MAC address of the user 1. It matches the MAC address that I'm showing you right there, as you can see. And yeah. And then here we have router advertisement. So router solicitation, router advertisement will actually, it's the router responding, replying back. So this is the link local IPv6 of the router. So let me show you this. Okay, let me show you this. Gonna move this one here. Let me move this one. Move this one right here. Then what I'm gonna do here, this is the let's say R1. Do show IPv6, okay, interface brief. Okay, so as you can see here, the link local IPv6 address, it's right here, FE80::1, and this is FE80::1. It's actually, that's the source. The message is coming from the router and going to destination all nodes multicast. So it's sent as a multicast, and it's called router advertisement. So to understand this and to clarify this, we have router solicitation. Router solicitation basically is coming from the host asking the router for an IPv6, and it's sent to all routers on the network. This is multicast address for all routers, destined for all routers. The source is the user 1, and sending the message as an ICMPv6 to all routers, multicast address, asking for an IPv6. And then, as you can see, the router reply back with an IPv6, and it's sending it to the multicast group, okay, all nodes multicast IPv6 address. Let's move to the neighbor solicitation message here. So as you can see, we have neighbor solicitation. Where is neighbor solicitation? Well, right here. Yeah. Let's get the next one here. So router neighbor solicitation message. Yeah, neighbor solicitation message. As you can see, it's actually like the R protocol, and what it does, it's actually when a host tries to resolve the IPv6 address to a MAC address, okay, it will send actually the ICMPv6 neighbor solicitation message asking for the gateway, default gateway IPv6 address. So the destination is going to the all nodes multicast. It's sent to all nodes multicast IPv6 address. And let's see the neighbor advertisement. As you can see here, it's coming from the 2001 DB ACAD 10, and then the last 64 bits are appended, and it's using the this is the global unicast IPv6 address of the host. So this is neighbor advertisement. So this is not a reply to the okay. We should see a reply neighbor solicitation. So this is coming from the router, going to the host, to user 1 host, neighbor solicitation, and neighbor advertisement is coming from the host, going to all as you can see here, to all nodes, no, going to the router. So now we can see clearly the neighbor solicitation here. Neighbor solicitation basically is a message sent from the router and is actually destined for the user one computer. And then the reply back neighbor advertisement is coming from the user one and going to the router. So basically, the router asks the user one computer for the MAC address, and the router responds with its MAC address, as you can see. So source and the destination address. So I think we understand the. Let's clarify more, actually, better the idea of the RA and RA, RS, NS, NA. Okay, so I think we, yeah, the host gets an IPv6 address, we configure DHCP, and everything is fine. So let me minimize this window, and let's go to the, let's go to the static configuration. So static configuration of an IPv6 host, as you can see, we can actually configure it statically. If it's server, then we should just actually select use the following IPv6 address, type the IPv6 address, and then the prefix lint, by default, it will actually show the 64. And then you need to specify default gateway. If you are using a DNS, if you have DNS, local DNS running IPv6, you could use your local DNS, or you could use local the DNS servers on the internet. Let's move forward here. Actually, move forward. So we configured the link local, dynamic addressing for IPv6. Yeah, that's the ones that I want to actually talk about a little bit. So yeah, so we have the three options for a host or a device, network device, to get an IPv6. In the information regarding IPv6, we get this information. So the prefix and the prefix lint, default gateway address, DNS address, and domain name. Those information, they could actually, host could get them either through SLAAC. SLAAC, basically the host itself, okay, PC, contact the router, let's say router here, and then let's say DHCP v6, DHCP v6 right here. So the host actually contacts the router, asking for it, send actually the RS, neighbor solicitation message, asking for the prefix and all the information. So when the router gets the message via ICMP, it will respond with RA, router advertisement, the IP address, gateway, and all other information. This is called a SLAAC, stateless auto configuration. Remember those actually methods for the CCNA exam and also for your IT carriers. So there are three methods we can get IPv6 addresses. The second method is the SLAAC plus with DHCP server, as you can see here. Okay, so let me move back. I think my pen is yeah. So SLAAC plus the DHCP server. So in this case, the host will send the RS to the router. The router will respond with RA with only with the prefix, and then the rest of the configuration, the host will actually send request the other information from DHCP. That's called SLAAC, stateless auto configuration plus DHCP v6. And the last option is a stateful DHCP. So the host contacts DHCP server and gets all the information from there. It's called, okay, stateful DHCP v6, and there is no SLAAC. So yeah, this is method one. So it gets the prefix, and then the last 64-bit, as I mentioned, as I showed you on the Wireshark, the packet that we sniff. So extended unique identifier means that the host actually take its MAC address and insert FFFE right in the middle between the organizational unique identifier right here and the vendor assigned. Okay, yeah, in between the first 24 bits of the MAC, okay, and the last 24 bits of the MAC address. That's called extended unique identifier, or it could be randomly generated. And this is actually for security reasons. Some people, they don't want people to guess what is the interface ID of their IPv6 IPv6 address. So as you can see, as I mentioned here, I want to elaborate on this a little bit because yeah, things probably are still fuzzy. So the host actually send RS router solicitation message asking the router for an IPv6 address. The router respond with RA message. It could send the all information that's called SLAAC. Okay, that's called the SLAAC, the first method. Or the host could send RS message to the router asking for IPv6 and then contact the DHCP for the other information. Okay, that's called a SLAAC with DHCP. Or the host could contact only the DHCP server to acquire all the information regarding the IPv6 address. Multicast addresses. So as we mentioned, the multicast addresses, as you can see, as I showed you on the Wireshark packet filtering that we used earlier. Let me actually get it right now. Let me show you this on the top here. So yeah, it's let me minimize this window here, and yeah. So as you can see here, we have the yeah, FF02::2. It's all routers, okay, all the routers multicast IPv6 address, or all nodes multicast IPv6 addresses. The range of those IPv6 multicast addresses are FF00/8, means that the first two digits of hex, they need to be FF, and we don't care what comes after that. Okay, so remember the multicast IPv6 addresses for the exam. Yeah, let's go back. So IPv6 multicast addresses. I want to mention, yeah, this is the all, as you can see here, this is the all nodes, okay, all devices, I mean, including routers, switches, hosts, all nodes. And then we have all routers. This is actually destined for all routers. If hosts want to actually send an RS router solicitation, then it will send it to the all routers in a multicast, okay, message. So yeah, finally, we're gonna see how to subnet an IPv6 network. We don't be worried about subnetting because we use /64 prefix lint. So the rest of the ID is 64 bits. So 2 to the power of 64 will give us approximately, yeah, it's exactly 65,526, which are a lot of IPv6 addresses. So we don't need to worry about the subnetting. But in case if you are working with an ISP, and the ISP basically, when they acquire an IPv6, they get the first 48 bits, and then they use the last actually 16 bits for subnetting. They can actually use subnetting, so to allocate the customers subnets from the last 16 bits. Yeah, for example, they could start here with yeah, you could write the 16 bits, and then you start incrementing, for example, the last bit by 1, 2, and going all the way to F, and then you start incrementing the second octet right here, okay, 1, 2, 3, all the way to F, and start incrementing the next, okay, and next, and next, and next, okay. And you don't need to worry about the interface ID is actually added by the host itself, either using the MAC address, which called the inserting the MAC address right in the middle of the inserting FFFE. Yeah, FFFE, need to remember that in the exam as well. Right in the middle of the MAC address is called extended unique identifier, or randomly generated 64 bits, okay, prefix. So yeah, as you can see, allow 65,536 subnets. So in this case, we could use, for example, we could increment the last digit. We could even, because each digit here in hex represents 4 binary bits, so we could even put it in binary, and then we start incrementing the binary bits, okay, and we get all these subnets. So that's the way we subnet. So in case you want to do some route summary or some exit lists, you want to filter traffic, so it's so helpful to actually use contiguous, okay, space, and don't waste IPv6 addresses. And that's the way of subnetting IPv6 addresses. So I hope this has been informative for you, and I would like to thank you for viewing.